Hi, today we're going to assemble this motorized camera slider so we can get into moving time-lapse photography for around $100. And of course this project is open source, so you can find all the required files and software linked in the video description below. Okay, so I have already laid out all the parts we need for this project, and again there's a full parts list including where to buy links linked in the video description below. So let's start with the two moving gantries, and the first one requires this aluminum plate, and I have painted mine black, but it's very simple. It's a 60 by 6 mm aluminum profile, cut to length and with 7 drilled and tapped holes. And there's a drawing for this also linked in the description below. So let's insert this into these two 3D printed parts, and here make sure to not use PLA. So I printed all these parts from PETG, and we will use 6 M3 by 8 bolts to secure the two parts together. And personally, for my setup, I have drilled an extra hole in the middle of the aluminum plate, so I can fit one of these quick change tripod plates right here, using a fitting nut and bolt. And note that here there is enough place for the nut, but if the screw sticks out of the nut, the two moving gantries will collide, so make sure to use the right length of screw. Now we can use these M5 by 25 screws and insert them in all the holes. We can now continue with these V-slot rollers, and the way we assemble these is to use one M5 washer. Then we put on this V-slot roller, and then we use one of these thin M5 nuts, and here it's important to use a thin nut, so again the two gantries don't collide. And there's just enough space to fit one of these nuts. So this is the first moving gantry for the tripod, and we can now start assembling the second moving gantry for the camera itself. So let's put this one aside and start with the two 3D printed parts for the other moving gantry. And as you can see, I have already pushed in 4 M3 nuts, and these are for the belt tensioners later. So just push them in, they should fit nicely, and if they don't fit, you can push them in just a bit and then use the screw from the other side to pull it in. Okay, so these two go together like this, and in between there's enough space for again 4 V-slot rollers. And so use the printed parts with these nuts is the bottom one. So insert 4 M5 by 25 mm bolts. And again, we will use these V-slot rollers, and here we use one washer, then the V-slot roller, another washer, then this 3D printed part, and then a nut. So let's insert all the washers and V-slot rollers. Now we use the second 3D printed part, and note that these holes are asymmetrical, so we we want to position this part that these holes line up with the nuts in the bottom, like this. Now we use one more washer, and again one of these thin M5 nuts to avoid any kind of collisions. If we want to use a ball head, tripod head, like this one, now is a good time to insert the right size tripod screw, which goes in the bottom of the ball head, like this. And there's a corresponding hole, and we just insert it from the bottom. Okay, we can now start to assemble the motor end. And here you can see I have already inserted 4 M3x5 threaded inserts, and they are just melted in using a soldering iron. So let's start with the axle required in this part, and for this I'm using one of these M5 by 100 mm hardened steel axles, and I have cut them here so that I get one 59 mm long piece and one other piece we will use later. So for the longer piece we want to use 2 bearings, one GT2 belt pulley, and one of the 2 gears included in the worm gear set. And we can use the 3D printed part as a guide. So we start by inserting the axle into one of the 2 bearings, like this. Then we want to use the 3D printed pulley, like this. Then we insert the gear, and then we use another bearing, like this. And we can use the pulley and the gear loose for now, and use the 3D printed part to line them up correctly. So just drop it in, and position both of them such that the axle can spin freely. And then we can use the grub screw and a small Allen key to fix them in place, like this. And if we turn it a bit further, there's a second one. And we want to use the pulley in this orientation so that the belt can come out of this hole right here. Like this. We can now take out the whole assembly again. And mount the motor. And on the motor I have already mounted the worm gear. So we use 4 M3x6 bolts inserted in these 4 holes, and there's one right here. I hope you can see them without them falling out, to mount the motor like this. And here we want to orient the motor such that the cable lines up with the small notch in one of the sides. So just push it in, and use the Allen key to screw in all the bolts. Like this. So we can now reinsert this axle. And use the motor end cover together with 4 M3x6 bolts to push everything in place. And here there's one side with a cutout, and this is above the worm gear. And with these 4 bolts we have to make sure to not over tighten them, or else the motor might stall. So just they should hold the cover in place, and there should not be much play. But if the motor stalls, just loosen these 4 screws. And that's the motor end complete. We can now go on to one of the arguably most difficult parts of this assembly, and that's the PCB end. And the reason for this is, as you can see, I have already assembled the PCB itself, and this is a separate video if you don't know how to assemble a PCB. But you have to route the wires of the motor through this little hole right here, which will later be covered by one of the aluminum extrusions. And then we have to solder them in place on the PCB while they are wired through this hole. And the same for the end stop. So we have to put the end stop on the outside, wire it through the end stop hole, and then solder it in place on the PCB. And this way we can insert the PCB and all the wires come out through the correct hole. So let's start by inserting the PCB right now. And so let's start by this DC to DC converter with the capacitor. And it should fit in without any problems. But it is a bit tight in here, so be careful with all the wires, so we don't want to rip them out or crush them with the PCB. And right here we want to put all the wires next to each other, not above each other, so we can insert the PCB like this. And at the same time we make sure there are no wires in the way right here. And we should be able to slide the PCB in without any problems. And if you're wondering what these 4 wires are, these are for programming. But if you have programmed the chip in advance and don't plan to contribute to the web interface on GitHub, you don't need these wires and you can just cut them off before inserting the PCB. But in my case, I will route them through one of these top vents, so we can program the slider later. So before we put on this cover and insert the end stop all the way, we use this leftover 5mm axle part together with this idler. And this idler has a 5mm bore, and we want to put it right here. And we will use some small pliers to insert the 5mm axle. And the way this works is, if you buy a 10 centimeter long axle, this part fits right here, but it requires you to put it in the hole for the end stop. Like this. And we can now, without much pressure, insert the axle into these 2 plastic parts, and be careful not to break them off, because they are designed to be loaded in this direction by the belt, but not sideways. So if the axle doesn't fit quite nicely, maybe you put a chamfer on it with a file, or try to print this part again with larger holes by using the XY offset to shrink the part in all directions. So with this set, we can now insert the idler and push the axle in all the way. And if you want to, you can use a small bit of super glue to secure the axle in place so it doesn't go side to side. But in my case, this is not a problem. So we can now insert the DC to DC boost converter with the capacitor, as well as the end stop. But be careful not to rip out any cables, or we have to disassemble everything again. Like this. And like this. And there's really enough space in here, so it's not very tight. We can now use the PCB cover, which is this part. And as you can see, it has 2 small holes here and here. And this is planned to be used like this, so we insert it. And it is a press fit, but in case it is too loose, you can insert small M3x4 or M3x6 bolts here and here. Just be careful not to damage the PCB if you screw them in. We are now almost done and can go on to use the two rails. And the way I like to assemble it is to mount the rails to the PCB end first, then add the two moving gantries, and then add the motor end. So we will use 4 M3x8 screws together with these T-slot nuts used on most 3D printers. And we will insert the screws from the top. And if you want to, you can use 4 additional screws from the bottom. But in my case, 4 screws is enough, as this fit is very tight. And we don't want to tighten these screws all the way yet, so just put them in and make sure to line up the T-slot nuts in this orientation so we can insert the two rails from the front. So we can now insert the rail, and this should be very easy. And if it binds, you have to file down the 3D printed part and don't force it, because if you push it in with too much force, the 3D printed part will break like this and right here. And if this part cracks, I wouldn't put my expensive DSLR on it. So be careful and don't force anything. It should fit very easily. And we just make sure we don't pinch these wires, as there is a channel in the middle for the wires themselves. We can now insert the other extrusion, and again it should go in very easy, like this. And don't tighten these screws yet. We will now insert the camera moving gantry, and as you can see, the 4 holes for the belt clamp are off center, so they are asymmetrical, and in this orientation we want the holes to be on the same side as the idler hole, which is also off center. So on my side the idler is closer to me, so we want to orientate the moving gantry in a way that these holes are also closer to me, like this. And we can now put on the second moving gantry, and again these 2 holes for the belt clamp are off center, so in this orientation they are closer to my side, and in this orientation they are closer to the opposite side. Otherwise this part is symmetrical, so you can orientate it to fit the idler orientation on the PCB end. But before we put this part on, we want to insert the wires for the motor inside one of the slots of this V-slot extrusion. Like this. And as this part fell out, I will just put it back in. And we can now make sure to use the gantry in the correct orientation and slide it on to this V-slot extrusions. And make sure not to rip out the wires. And there is a bit of force required to put on the second moving gantry, as these 3D printed parts are used to clamp onto the rails, so there's no slop in the system, but don't force it or the 3D printed parts might break, so be careful. And now, to take out the slop of the second moving gantry, we want to push these 2 rails together with our hand and then tighten the T-slot screws. So before we tighten them, we loosen them to get the T-nut spinning freely, and then we tighten them. and make sure to apply pressure with your other hand onto the rails to take out any slop for the middle gantry. And if we look this way, we can check if the T-nut has turned correctly, so it should now face this way. And again on the other side, apply pressure with your hand, loosen the screw and then tighten it all the way. And again, you can check by looking from the side if the nut has turned correctly. Okay, so I have not yet tightened the back two screws, and we will do this after we have inserted the motor end. And again, we use 4 M3x8 bolts and 4 T-slot nuts, or you can use 4 additional screws from the bottom. And again, we should be able to insert this part onto the rails without much force. And be careful not to split the 3D printed part right here and here. And also be careful of the wire so you don't rip it out. So once we have successfully inserted the motor end, we can move both gantries to this side and again apply pressure with our hands, and we loosen and then tighten the front two screws. We can now check if both gantries can move freely. So there shouldn't be a problem for the outer gantry, and the inner one should move and have no slop. If you try to push it side to side, you are not supposed to hear any clicking. Okay, so now that this is done, we can insert the belt and then tighten the last 4 screws before we are done. And you can now see why I have not put on the cover on the PCB side, and this is to insert the belt. So we will insert it from the bottom. The top part of the belt will now go below the aluminum plate. And the bottom part of the belt will also go below the aluminum plate, and we can screw it in right now into the inner moving gantry using one of these belt clamps and 2 M3x12 screws. We will now remove the cover on the motor side to insert the belt. And we should be able to take out the axle with our fingers. Otherwise we can use some pliers, but be careful not to scratch the gear itself. We will now insert a loop of the belt through the hole in this side and put it out the top, like this. Now we can insert the axle and reinsert the axle with the belt attached. But before you do so, make sure to move both gantries in the middle, as the worm gear is not back drivable, and so we have to use the gantries to tighten the belt. So make sure they are both roughly in the middle and not all the way to one side before inserting this axle. Again, make sure it's seated nicely by wiggling it around. And then we can put on the cover again, making sure that this cutout is on the same side as the worm gear. And don't screw these screws all the way in, or the motor might stall. We can now move the outer gantry out of the way and use the inner gantry to tighten the belt, using again a belt clamp and two M3x12 bolts. And now we can use pliers to pull on the belt like this. While at the same time tightening this belt clamp. And the belt, it's not that important that the belt is very tight, but it should be tight enough so it doesn't slip on the idler and the pulley. But you also don't want to over tighten the belt to the point where the plastic parts start to bend. Now that the belt is secure, we can secure the second gantry to the belt. But before we do that, we can insert one of these plastic covers for the V-slot extrusions to hide all the wires. We just slide it in place. We can now use a power bank with two outlets, like this one, and two USB cables to power the slider. And the way this works is that one USB cable powers the electronics and the second cable powers the motor. So you can also use two different power banks if you want. And you should see a red light, and from this side a blue light. And you can now use your phone. And you should be able to find the slider Wi-Fi and connect to it. Once you are connected to the slider Wi-Fi, you can enter the slider IP, which we defined in the firmware. By default, it's 192.168.5.1, and you should see the slider web interface. And if you now angle the slider like this, that it can move freely and push home, we should see that the slider starts moving. And we can also fine-tune the screws on the cover for the motor if there is any binding. And once the camera gantry reaches this side, we will manually push the end stop. And push and hold the end stop. Don't just push it. Hold it until everything stops. We can now put away our phone. We can now start to secure the other moving gantry by moving it to this side until it touches the end stop. And you should hear a click. And we will use the last part remaining, which is the last belt clamp, together with two M3x6 screws. Okay, we are now done assembling the slider, and we can leave it for travel like this. And when we want to use them, we can screw the ball head onto this screw. just make sure it's orientated in a way that these knobs don't hit the V-slot rollers. And that's it.